Hi, Ricky here. This is LeetCode question number 278, first batch version. This is easy question. Let's get into it. Alright. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product failed the quality check since each version is developed based on the previous version. All the versions after a bad version are also bad. Okay, suppose you have n versions start from 1 to n, not 0. And you want to find out the first bad one, which cause all the following one to be bad. You are given an API, bool's, return value is bool, is bad version, and then argument is the version, number of version, which will return whether version is bad. Implement a function to find the first version. You should minimize the number of calls to the API. Okay, that means we need to care time complexity, right? Okay, let's check the example. Given is the number 5 is 1, 2, 3, 4, and 5. And from where? From version 4. And then this is bad. So when we call API, it return true, right? True, because that is bad version. And then before 3, it return false. Okay, let's brainstorming. Okay, what is the best approach, you think? I think the proper solution is we will use the linear search. So from the start, 1 check first, no, 2 check first, no, 3, 4 check, no, 4 check true, yes, true, and return this one. But maybe is there better solution? Is there any better solution? Yes. What is this? Yeah, that is binary search. Actually, when you use linear search, it takes linear time. But when we use binary search, we can reduce it to big O log n. So in this time, we will use binary search. But maybe you have a question if you're using binary search, because binary search is a technique to find only one value in the array or in the set. But in this time, we needed to find at least 2. One is to find the return the bad version is true, and then one of previous version must be false. That means that is the start of bad version, right? So basically I will use binary search, and then I will a little bit modify it to use first bad version. Okay, let's implement code. Okay, binary search used two pointer techniques, so I will define two pointer. Name is left is the initialized with 0. Oh no, not 0, right? Because it starts with 1 and then until n. So left is 1 and right is n. Okay, let's iteration. Left is while left is smaller than right. And then okay, let's calculate the mid value. Mid value is left plus right minus left divided 2. And then maybe you have one question. Why you not do left plus right minus 2? Because this is much simpler. But one of the issue of this one, okay, let's assume that mid is the only integer value, and left and right is only the left is in boundary of integer, and then even this one is the in boundary integer, but that is not guaranteed. The sum of left and right is in bound of integer. So if we use this one, maybe we face on the integer overflow. So okay, this one also they're the same, but possibility is much lower than the second one. So I recommend please use the line 15, not 16. That is better. Maybe if you use the like 16, I think you may get extra credit from interviewer. Alright. Mid, and then okay, let's check mid value. If is bad version and version is the mid is true, and then that is candidate one of we looking for. So at that time we will check one more thing. If not is bad version, mid -1. If this one true is okay, maybe we are here. 3 is first, 4 is true. This case is the same of this case. This one is true, and then this one true, and then this one first, and then this one first. Then this is the first bad version, right? So in this case, we just return with value. Otherwise, we need to decrease boundary. So in this time, this value, mid value is bad means above all of this one is bad. So no need to check this one, right? So we can reduce the boundary. Right is mid -1. Is it making sense? Yeah, that is basic case of recursion relation of binary search. Okay, then right is mid -1, else left is mid +1. Okay, let's run. Oops. Okay. Left, right, and mid, left, right is okay. If it's better to mid and not mid -1, return mid. Otherwise, right is mid -1, as left is mid +1. Okay, -1, return mid. If not bad version, mid -1, mid, left, right. Sorry. Okay, let's submit. Okay, let's check complexity. Time complexity is log n because we use binary search, and then space complexity is constant space because we do not use any extra data structure. Thank you.